12s, welcome back to the second part, or the second video on indefinite integrals. Remember, to find the indefinite integral, we need to find the primitive, the antiderivative, make sure there's the constant on the end. That's the end of it. We don't usually have to substitute in. Now, just for consistency with the textbook, worked exercises throws a couple of definite integrals in here as well, because mostly what we're doing is we're looking at more complicated examples. Because we can already integrate lots of stuff when we're doing definite integrals. Indefinite, well, we just don't have to substitute in. There are some examples here where we're going to do that as well. Sure. So let's have a look at what we do when there are fractional or negative indices here, and we're going to evaluate them. Well, the first thing we want to do is rewrite this with a fractional index. So that's the integral from 1 to 4 of x to the half dx. Now, to integrate this, that gives me x to the 3 over 2, right, divided by 3 over 2, or times 2 over 3. Right. Now, we don't put the plus c in here because this is a definite integral, because I've got bounds here from 1 to 4. Now, I substitute those things in. 4 to the 3 over 2, well, 4 to the half is going to be 2, 2 to the 3 is 8. So that's 2/3 of 8. Let's say that's 2 times, 16 over 3. 16 over 3 minus, let's evaluate the other part is 2 over 3 equals 14 over 3. No plus a c, no plus constant here on the end because we've done this substitute. The two c's essentially cancel each other out. Righto. Again, over here, this is a definite integral because I've got bounds here. But now I have a negative fractional index. We just rewrite that. The integral from 1 to 4 of x to the negative half. Negative half dx. Okay, so we are going to raise that by 1. So that gives me to the half. That's x to the half divided by half, or times 2. 2x to the half. Righto, that's pretty good. From 1 to 4, no constant on the end because this is definite. We've got bounds here. Now, this equals 4 to the half is 2, 2 is 4, 4 minus 2 equals 2. There's my answer. That's a neat one. Righto. So, if we have square roots, if we have x in the denominator somewhere, get to work with your index laws, rewrite those as fractional or negative indices to follow those patterns. Now, there is another example that I want to look at here. One more thing. It says these are always difficult. And there's also a note there that says in 2-unit, you'll never have to do these without having to sort of do this first step where they kind of give you the answer as you go along, which I think makes it not so hard. So what we're going to do, we're going to differentiate this thing first. What have I got? I've got a function of a function. So the differential, then dx, of x squared plus 1 to the power of 4. How do I differentiate this? Well, function of a function, I get 4 x squared plus 1 to the 3 multiplied by the differential of what's inside there times 2x. So I get 8x outside of x squared plus 1 to the 3. That's part A done. For part B, hence, find the primitive of x squared outside of x squared plus 1 to the 3. Well, we have just differentiated this function here, and we got this one. Find the primitive of this just means go the other way. So I'm going to say the indefinite integral of 8x outside of x squared plus 1 to the power of 3 dx equals, well, we know it's x squared plus 1 to the power of 4. Okay, it says they're always difficult. I don't know that that is so much because I think we're given enough information to really point us in the right direction all the time. Anyhow, certainly very difficult answering that second part without the first part. That would be difficult, but that's not what you're going to be expected to do. Okay, that's indefinite integrals with a couple of definite ones thrown in there to keep you on your toes. More complicated examples definitely here. Right, we're going to look at making these harder and harder. There's nothing particularly new in there, but you're just going to have to stay on your toes, work on these, do plenty of examples. We'll work through them in class. I'll be there to answer your questions, help you out as you go along. Thanks, guys.